I'm going to do a little bit longer of an example. It's actually two problems, more like a part one and part A and B of the same problem. But we're going to look at displacement in two dimensions. We're going to include north, south, and east, west. So we'll use north and south as the y direction, east and west as the x direction. So let's say a ship sailing on the ocean, and it goes 20 kilometers north, 45 kilometers west as it sails in a straight line. We're going to look at that displacement. So as we do that, write down everything you know, identify any knowns or unknowns that you're trying to solve for, and we're trying to figure out how far away it's moving, how far away it's moved, and what angle is it moving. So to do that, we need to draw a diagram. You treat it as a right triangle. Let me show you what that looks like. So we have the 20 kilometers north, the 45 kilometers west, and you notice I put a negative there because the 45 kilometers is in the westward direction, which is in the opposite direction of east, which when we draw it on a normal compass points to the left, which we'll write as negative. So that means our overall displacement points at an angle somewhere between west and north. So the way you describe that angle is north of west. So to do that, we can find the magnitude just using Pythagorean theorem. So we have a negative 45 kilometers squared. It's a lot easier a lot of times not to even include the negative, just to have both through there. But you end up with about 49.24428 blah, 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 blah kilometers, which I'll round in most cases because you're given the information to two significant figures. Might as well use the same number of significant figures there. So the idea is the overall displacement will be 49 kilometers. Now we want to find the angle. The angle we'll set up with the right triangle using the tangent of the angle. So it's going to be 20 kilometers north, 45 kilometers west. That gives us an angle using the inverse tangent of almost 24 degrees. So 24 degrees north of west. It's pretty close there. But most of the time, unless we want to specify the direction explicitly, we'll usually do that from east or the positive x direction. So that means it'd be 180 minus 24 degrees or 156 degrees from x, the x-axis, or due east. Now let's say part B. The boat turns and makes a heading that's 30 degrees east of north and continues for 55 kilometers. So we want to find how far it's gone from the original position. That's from where it started in part A. So we have to figure out what we know, what we don't know, and then sketch the problem. And make sure we write out anything necessary as we're solving. So our known is that originally we had a displacement of 45 kilometers west, 20 kilometers north. Our second displacement is 55 kilometers at an angle of 60 degrees north of east. So we don't know how far east and north it travels, or the overall displacement and angle. So we'll draw those out. This one's a little bit trickier. So if we look at it, our first displacement is northwest. Then the second displacement is northeast. So our overall displacement looks like, depending on how I've drawn this, is going to be somewhat northwest. All right, so we need to find the x and y components of that second displacement. In this case, because the triangle is a little bit switched, we have the x direction being sine, the y direction being cosine. So now we have those components. Once we have those components, we then add them to our original components. So our x components were 45 kilometers to the west. Now we have 27.5 kilometers east. So that means an overall horizontal displacement of 17.5 kilometers to the west. Then to the north, both are north. There's no south displacement at this point, of 20 kilometers in the first displacement, 47.6 kilometers in the second, which gives us an overall displacement of 67.6 kilometers. Now finally, we can use that to set up a right triangle to give each of those pieces there, which gives me an overall displacement of approximately 70 kilometers. By adding those components, by x squared plus y squared equals r squared, and we're able to find that piece of 70 kilometers. But then, overall, we can find the angle. The angle is going to be the inverse tangent of the y over the x. So it's going to be 75.5 degrees north of west, which is 104.5 degrees, which looks somewhat like this. So when we solve for the angle, we solve from the angle between the negative x-axis and our line, just because of how I did the triangle. But now if we have these pieces here, you get an angle of 104.5, which matches with what we sketched out before.